Welcome to BKW Physics. I'm Mr. McConley, and what we're going to do today is do projectiles fired at angles. So previously we did projectiles fired horizontally, and we learned the rules or the tricks to that, and this is just the next step in the process. So I have a situation here where I said the vertical component of an initial velocity is 14.7. The horizontal component of an initial velocity is 300. So you can see that this is a very large number. This projectile is mostly being pushed forward, but it is being pushed up a little bit. And maybe, for example, it might be this cannon picture. Excuse my terrible art ability here on this picture, but what we have here is we got to treat this, we're thinking in our minds, yeah, this projectile is going to be fired in an arc like this. But that's not how we approach the problem. The way we approach the problem is we actually do components like vectors that we've done previously in this class. So if we take this and we say in this direction we have a 300 meter per second vector, and in this direction we have a tiny little 14.7 meter per second vector. That's a much better start to what we want here. And if we think about it, where's our resultant going to be? Well, if we move this one down here, tip to tail, our resultant is going to be that the actual launch is going to be out in this direction. Okay? So we know that this projectile is going to go up in the air, and it's going to come back down, and it's going to land somewhere over here. Everyone seems to agree with that. Well, let me ask you this first thing. How much time, how long time to reach the highest point? How much time is it going to take to reach the highest point of its flight? Well, we're going to go back to another old equation that we've used quite a bit. Acceleration is the change in velocity over time. Okay, that's an old equation. And in this case, since we're worried about time to reach the highest point, we're worried about an up and down direction, a vertical direction, we're going to change this to gravity. Okay? And then we're just going to rearrange the equation. So I'm going to multiply time by both sides. I'm going to divide the g over. I'm going to get time is the change in velocity over gravity. And I'm going to add one more thing, just like I did in the last video. Since this is gravity, it's up and down, so this velocity I'm dealing with is also up and down. I'm going to put a little v there, meaning it's vertical velocity. Okay? And it's the change in vertical velocity. So when my projectile, back to the picture here, when my projectile is launched, this number, the 14.7, is the initial vertical velocity, the v sub I sub v, initial vertical velocity. Well, follow the picture through here. The projectile goes, okay? We're worried about this point right there. What is the vertical velocity way up here at the top of the picture? In other words, how fast is the projectile going up and down when it's at the top? Can everybody see? 0. It's not going up and down. It's reached the top. So our vertical velocity, and we can call it final if you will, F. Our vertical velocity here at the top of the flight is going to be 0. So what's our change in vertical velocity? We started at 14.7, we ended at 0. Oh, it's 14.7 meters per second. And gravity is 9.1. So when we divide those two, let me just check here. Yeah, it comes out about 1.5 seconds. That's the time it's going to take when it's launched to reach its highest point. So what if I change the question a little bit and I said, what's the total time of flight? You would simply say, oh, that's easy. If it took 1.5 seconds to get to the top, how long is it going to take from the top to get to the end? Ashley? So it's going to be a total of 3 seconds. Done. And it is that easy. Okay, the total time of flight is just 3 seconds. Because the time to the highest point, that's the halfway time. Okay? The next thing you're going to want to work on is how high. How high. So, how high is that point right there? How high is the highest point? And we're going to again revert back to the equation that we learned in the previous video, which is dv equals VIVT plus 1/2 GT squared. Now in the last video, I told you that you could eliminate this term right here because I said that your initial velocity was 0 because in the last video we were throwing something off a cliff. We were throwing it horizontally, we were throwing it flat. Can I eliminate it this time? No, I can't. Because this time I'm actually throwing it up in the air, so I actually have to use that number. So let's go ahead and figure out how high. We're going to use 14.7 meters per second as our initial vertical velocity. What time do you think we're going to use, Cheyenne? Because we want to know how high. Are we going to use the 1.5 or the 3?
1.5.
Yeah, the 1.5. Good instinct because I'm not really concerned about way over here. I'm concerned right there. And if I'm concerned right there, I need the time right there. So I use my 1.5. I do 1/2. I do negative 9.81 meters per second squared. And I take the time on the end and square it. Now to save a little bit, I did the math ahead of time. This comes out to be about 11 meters. I'm rounding there, but it's 11 meters high. So you can say that, oh, this projectile traveled 11 meters high. Okay. The last question I might ask is how far? Or what's the range? How far did this thing go? And again, I'm going to go back to the same equation we learned in a previous video. If you want to know how far, you can use this equation because this equation is based on a constant velocity. And believe it or not, once this cannonball, once this projectile leaves the cannon and it's going forward at 300, it will continue to go forward at 300 until it hits the ground. And if you don't believe that, go back to the example I gave in the last video where if you're walking along and you throw a marker up in the air, it'll come back down and land in your hand even if you're not looking at it because it continues to go forward at the same speed. Okay, that being said, that's a really key concept if I keep saying it. The velocity in the horizontal direction is 300. Now, in this particular instance, Dana, do you think we're going to use the 1.5 seconds or the 3 seconds? You want to know the range. You want to know how far. You want to know over here. And you are right, you're going to use 3. So I'm just going to do 300 times 3. I'm going to get 900 meters. So we have learned how far, how high, and how much time it took to get to the highest point, how much time it took to get to the total distance. So for today, we're finished.